Hey class, this is Mr. Benzing. I'd like to go over a couple of examples. I'd like to just go quickly over how to use the reference pages that I gave you in class for you, and also have linked on the assignment so that you can have access to them at all times. You're looking right now at the beginning part, like the first page of the reference pages. So take a look at table C where it says selected prefixes. Take a look at this area that is like right here in between 10^3, 10 to the third, and 10 to the -1, or kilo and deci. And you'll notice that in between these two here is this thing that is like where we have our meters, our liters, and our grams. And what I'm referring to actually is this whole chart that you see here. So anything that's on this chart that I'm like the red arrows or the red lines are going to fits in here where it says 10 to the 0 power. So 10 to the 0 meters, 10 to the 0 liters, blah, blah, blah. That actually ends up being extremely important when we go from one prefix to another, especially because we use these the most, where it's like meters to centimeters, or liters to milliliters, or kilograms to grams. And we need to know where the grams place is on this selected prefix table. Okay, so let's keep going here. First of all, the first thing you want to do is take a look at the other table. Let me go back again, and you'll see table D, selected units. All of these units here are things that we measure in science, like M for meter for length, G for gram for mass, and so on. So as you go down here, when it says mass, obviously you're looking here, and then you can put the symbol where you are there. So let me show you what that means. Mass here is G, of course. The one that people always ask me is time. Mr. Benzing, there's 4 different times there. It's actually like 6 different times. You can do seconds, you can do minutes, you can do hours, you can do years, you can do whatever you want there. And then for volume, like temperature, energy, pressure, look those up and put the symbols down there just to get you familiar with them. And then we take a look at this, and we got 10 to the 12, and of course that's pico, so you got to be careful with that. Nano, that's nano, there we go. And then micro. Now micro, it says by adding the prefixes, make sure you know that micro looks like a U with a tail on the front. Okay, and then there's milli, and this one is the base unit. That's the one that's a table D or table B or whatever it is. And then 10 to the third, of course, is kilo. Okay? So if a substance weighs 2 grams and you need the mass in kilograms, will the number appear to become smaller or larger? I just want to do one of these examples, and then hopefully you understand that and can do the rest. Excuse me. So if it's 2.00 grams and we want to change that to kilograms, that means that I'm going from grams to kilograms. Now you guys know, you've watched the Ed puzzle, so you know how to do this. We got the 10 to the 0 for grams. So what I'm going to do is just use the 0, and then I'm going to a +3, so I subtract 3, which means that I have a -3 here. So this is 10 to the 0 for grams, and we're going to kilograms, which is 10 to the third, like this. And I always subtract where I start and where I'm going to, and that means that I'm going to the left, okay? Because it's a negative. If it's a negative number, I'm going 3 places to the left. If it's a positive number, I'd be going 3 places to the right, which means to the left means 1, 2, 3, 0, 0, 0, which means this is what I have for kilograms. Now take a look. I went through all of this to show you that grams is 1,000 times 1 kilogram is equal to 1,000 grams. Okay, that's what that kilo means. It means 1,000 of the base unit. So if you need the mass in kilograms, will the number appear to become smaller or larger? Obviously the number becomes a lot smaller. Okay, 1,000 times smaller. And explain your answer. Why does the number become 1,000 times smaller? Because grams is a much smaller unit than kilograms. It's 1,000 times smaller than kilograms, so if we make the unit bigger, okay, of kilograms is bigger, then the number has to go the opposite direction. If the unit gets bigger, the number gets smaller, okay? If the unit gets smaller, the number gets bigger then. Like it works like a seesaw. If one goes up, the other goes down. Okay, all right. So let's keep going here. I don't want to make this too long. I'm going to do a couple examples here. Convert the following. I'm going to do exactly what I did before. Kilo is positive 3. I'm going to subtract meters as a base unit, which is 0, so I have 3. That means I'm going 3 to the right because it's positive, which means my decimal point starts here after the first or after the last digit. 1, 2, 3, which means I have 900,000 as my example there. Okay, notice I'm going to skip over to H here. I'm only going to do 1 or 2 examples, so I want you guys to do the same thing. I want you to practice this. Milli is a negative 3. Okay, if milli's negative 3, then meters is of course a 0, which means I'm at a negative 3 here, which means to the left 3 places. There's my decimal point, excuse me. I go 1, 2, 3 places to the left. My answer is 0.568, like that. Okay, that's how I do those problems. Let's keep going because there's more questions here. Determine the number of 1600 per meters. Okay, that's easy because we start in 1600. That's where the number starts, like this. And I'm going to millimeters, which means 0, minus, and then a minus 3. That gives me a positive 3, which means to the right. Okay, so if I'm going 3 to the right, that means I'm going 1, 2, 3. I got 1, 6, 0, 0, and then 0, 0, 0. Okay, so that is 1,600,000 millimeters. That's how I do all of them. Okay, I do them all exactly the same way. Whichever unit has the number is the one that I start with. That's a minus 3, minus, and then whatever one I'm looking for, which is 0, so that's a negative 3. You know I'm going to go 3 places to the left. So that's how they all go. Let me just make sure I'm not missing anything here. They all work exactly the same way. Everything you see like this, milli would be, of course, in minus 3, and we're going to grams, which would be 0. So that would be a minus 3, 3 places to the left. Okay? They all work exactly the same way. All right, good luck.